we're back. So where we left this off last, our consumable was fetching all the attributes off the player and was fetching all the buffs off the object, and then looking for names that matched. When we find names that match, we want to do that buff work and then kill ourselves. The kill is already implemented in the destroy here, but let's do the nitty-gritty here. So for each, what does it mean for the attributes to match? We're going to do the work if the names match, right? So how do we check if the names match? So we're looping through all attributes and all buffs. So if attrib.name, in C# we can use equals equals. It's equal to buff.name. They match, so apply the buff to the attrib. And our int data implements an interface for us to do that apply. We will probably want to, once we have two or at most 3 of these, we'll probably want to refactor this and push this inc and set stuff into the base. But to get this consumable working, let's do it directly. So apply the buff to the attribute. What do we want to do? Who gets added to what? Who gets added to who? Attrib dot inc data buff, something like that. Oh, but wait, what type of reference is this?
What type of reference?
It's a data. It's not an actual int data. We've got a reference to the base, right? So we didn't actually implement the interface in the base. So let's just do a little upcast and see if it passes. If it passes, it means it is this type, right? Now you can do the inc data. And we've got 2 different forms, one that takes a raw value, one that takes an int data. Let's assume that if they match, it means that if the names match, it means the data types match. That's probably not a safe assumption going forward, and I'm going to leave that in there deliberately because I want you to fix that for your assignment. Don't worry, you don't have your assignment yet. Okay? But that's our int data. And we could just pass that in, right? Because we have an inc data that takes an int data. Pass the int data into the trib for adding, for inc.
Why are there double brackets?
One's for the upcast and one's for the calling inc data. So I'm calling the increment data method on this int data component, and I'm passing it an int data, which is an upcast of buff, because buff is a data. See what happens. Odds of this working? 0. Let's see for better than 0. Walking through. Our hero has a health of 50. Do the walk. Our hero has a health of 65. And the object went away. Congratulations, we have an interactive object. We have a health pack that adds health and dies.
Mine doesn't increase.
So we're back in. So this works, I guess. Let's say we wanted to expand on our health pack, and in addition to it increasing your health, it also adds 100 points to your score. How could we change our health pack and make it a, golden health pack that adds 20 life and 100 to your score? What do we have to do now?
You just add another inc data with the name, score.
So we're gonna have a different object. Control D. This is our golden health pack. Okay. And it does something slightly different. And tell me again. We just do what?
Add and make data with a name score,
Sure.
and then set the data to whatever you want the score to
So
be.
quite literally, we're gonna add 100 points,
Cool.
and the health is gonna be 20 instead of 15.
Okay.
And
And you go to your player and you also have to add another make data with the name score and 0 probably.
really, that's all there is to it.
Yep.
Pop, and he turns really slowly. We need to fix that. And pop. Click on our player. Health is 85. Score is 100.
Wait,
So was it? So we spent a bunch of time writing some infrastructure, but we already saw it was really easy now to make a slightly different object. We didn't have to recompile anything. We didn't have to use inheritance to make this a score and health game object with polymorphism inheritance. We just had to use Haza.
So why do you have a spaceman?
Because he's floating.
Yo, my guy does almost the same thing. Just like goes off in space.
Oh, you add another